Hoo-hoo! It's a great day to be in geometry. This is Miss Legg-Battles, and I'm here today to talk to you about our second type of special right triangles, the 30, 60, 90 triangles. First of all, let's see if we can't derive the ratios for a 30, 60, 90, because remember, all the 30, 60, 90 triangles in the universe are similar to each other. They would all be similar by the angle-angle similarity postulate. So the first thing I'm going to do is draw a regular triangle. This is a regular triangle. So on your template, if you're copying that with me, that'd be number 4 on your template. So all the angles of the regular triangle are 60 degrees. 60 degrees here, 60 degrees here, and the third one is 60 as well, but I'm going to drop in an altitude. So when I drop in that altitude from the vertex angle there, that's going to divide my regular triangle into two 30, 60, 90 triangles. So now these angles are going to be 30 degrees. And you can see that the two triangles here are going to be congruent. The triangle on the left, the triangle on the right, congruent to each other. And they're both 30, 60, 90 triangles. Now, I could let the side length be x, but I'm going to choose 2x. That way I won't have fractions because I want the side down here to be represented by x. If I let this one be x, then this one would be 1/2 x. And what I'm going to do today is use the Pythagorean theorem to find the value for this side of the triangle in terms of x. So using the Pythagorean theorem, I would have h squared plus x squared equals 2x quantity squared. Now, I'm going to simplify by squaring 2x. And of course, 2x quantity squared means 2x times 2x. That's going to give me 4x squared. Then subtracting x squared from both sides, I get h squared equals 3x squared. And then finally, taking the square root, I'm going to have the square root of 3x squared. Now this will simplify, and I want you to notice that I'm ignoring that it would be plus or minus, because for this problem, h is the length of the side of a triangle, so we're going to ignore the negative. And I'm going to go ahead and simplify this by taking the square root of 3 individually from the square root of x squared. The square root of x squared is just x, and then the square root of 3 won't reduce. So h in my problem right here turns out to be x on the square root of 3. So now I have all three sides of this 30, 60, 90 triangle with respect to x. Now, I want to name these sides so we can talk about them, because remember in our 45, 45, 90 triangles, we just had the legs and the hypotenuse because the legs were congruent. But in a 30, 60, 90, they're not. So let's come over here and label. If this is my 30-degree angle and this is my 60-degree angle, obviously this is my hypotenuse. It is the side opposite the right angle in a right triangle. It's called the hypotenuse. I'm going to abbreviate that. Then my other two legs have different lengths. Now, they may not be drawn to scale, but we know one's shorter than the other one, instead of them being congruent like they are in 45, 45, 90s. So I want to name one of them the short leg and one of them the long leg. So let's talk about that. Opposite the 30-degree angle is going to be the short leg. As the angle is smaller, the side opposite that is smaller. So it is a leg, so we'll call it the short leg. And then the one opposite the 60-degree angle is longer, so we'll call it the long leg. Now, looking at my ratios over here, I'm going to write those in red here. The short leg is x, the hypotenuse is 2x, and the long leg is x times the square root of 3. So in words, that would be my hypotenuse is twice as long as the short leg, and the long leg is square root of 3 times the short leg. So everything is given with respect to the short leg. So if you don't know the short leg, we'll find that first. Now, let's look at the theorem that's written in words. In a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is square root of 3 times the length of the shorter leg. So one more time, I'm going to write those ratios in. If this is my 30-degree angle, and this is my 60-degree angle, then my short leg is down here. This is x. My hypotenuse is 2x. And my long leg is x times square root of 3. So we're all set if we know the short leg and we're looking for the long leg or the hypotenuse. But what happens if we know the hypotenuse and we're looking for the short leg? Well, if we know the hypotenuse, we can divide that by 2 to get the short leg. If you have to multiply the short leg by 2 to get the hypotenuse, you would have to divide the hypotenuse by 2 to get the short leg. In other words, we're going to undo that operation. The opposite of multiplying by 2 would be dividing by 2. And it's the same thing with the short leg with respect to the long leg. If you know the short leg and you're looking for the long leg, you're going to multiply by square root of 3. But if you know the long leg and you need to find the short leg, you're going to divide by the square root of 3. And then, of course, once you find the short leg, you can go back to the original rules to find the other missing side. Now, let's look at some examples. I prepared 3 examples for us, one where the short leg is given, one where the hypotenuse is given, and one where the long leg is given. So I have each case represented here. So in example number 1, 5 represents the short leg. See, this angle would have to be 30 degrees if this one is 60 and this one is 90. So opposite the 30-degree angle is the short leg. That's 5. So the hypotenuse is going to be twice that. So 2 times 5 is 10. And the long leg is going to be square root of 3 times the short leg. So the short leg is 5, and I multiply by square root of 3. Just get 5 on the square root of 3. So again, because the rule is written with respect to the short leg, this is the easy case. On the next problem, we're given the hypotenuse. So let's find the short leg first. X is the short leg. So if the hypotenuse is 2 times the short leg, then if we know the hypotenuse, we'll have to divide by 2 to get the short leg. So 14 divided by 2 is 7. That leaves 7 for my short leg. Then y represents the long leg. So for the long leg, we would have the short leg, which is 7, times the square root of 3. So the short leg is 7, the long leg is 7 times square root of 3. Now in my final example, we are given the long leg. The long leg is 6. So remember, if you know the short leg, you multiply by square root of 3 to get the long leg. But if you know the long leg, you're going to have to divide by square root of 3 to get the short leg. So the short leg would be 6 divided by the square root of 3. Now, the problem with this is there's a radical in the denominator. So we must rationalize. That means get rid of the radical in the denominator. And we do this by multiplying by square root of 3 over square root of 3. Now it's okay to do this because that's like multiplying by 1. What we're doing is we're changing the form of the answer, but not the value of the answer. So I get 6 on the square root of 3 in the numerator, and square root of 3 times square root of 3 is 3 in the denominator. And this will further reduce. I can reduce this because there's a common factor of 3. So my final answer for x would be 2 on the square root of 3. Now that I have the short leg, it's very easy to find the hypotenuse. I know this is the hypotenuse because it's opposite that right angle. So y, which is the hypotenuse, is 2 times the short leg. So that's 2 times 2 on the square root of 3. So that gives us 4 times the square root of 3. So there are my answers for this problem. Short leg is 2 on the square root of 3. Hypotenuse is 4 times the square root of 3. Now, if you have any trouble with these, I often encourage my students to go back in and label the side lengths. Label this. This is the short leg, this is the long leg, this is the hypotenuse. Same thing on these. On number 2, x is the short leg, y is the long leg, 14 is the hypotenuse. And on number 3, x is the short leg, 6 is the long leg, y is the hypotenuse. I'm sure you'll do great, and 30, 60, 90s are so important, and they're going to help you so much later on in your mathematics. Have a great day.